I built a server for just $100 and it was fine. So naturally the next step was to double the budget and see if it doubled the performance. Okay, we don't have to double the performance, but I do think that extra $100 goes a long way to create a solid starter system for your home lab, so let's check it out. Okay, we're done with this. Let's get the good angle here. Yeah, it looks good. This is my $200 server and everything was sourced directly from eBay or the masochist marketplace known as AliExpress. No local deals, no dumpster diving, because while that probably would be the most cost-effective choice, I'd like to show off something more achievable by everyone watching. If you want to see me make a dumpster dive server, then just let me know. I'm not above that, and I'm also not above this. This video is sponsored by UGREEN and the Nexode Pro 100-watt charger. With 2 USB-C ports and 1 USB-A port, it can handle fast charging of up to, 2 + 1, carry the 6, 3 devices. When using a single USB-C port, you can get a full 100 watts to your device, which is plenty enough to charge most modern laptops, even my daily driver M1 Pro MacBook Pro. It's quite literally the only charger I need to keep in my bag these days, since it can charge my laptop, phone, and any of my other devices at the same time. The Nexode Pro uses a gallium nitride infinity chip, which is a new technology to allow for a faster and more powerful charging experience. This basically means that they can cram a lot of power into a smaller package. I mean, just look at it compared to another 100-watt charger I have, and even against Apple's MacBook charger. You basically have no reason not to get one of these, especially since UGREEN has an awesome sale going on with Walmart to sell the Nexode Pro up to 50% off, so go snag one using the link down in the description below. So at the heart of this build is the Lenovo Thinkcentere M7200DT that I got off eBay for $121. Yep, more than half of my budget gone just like that, but I think I got a good deal here. It's got an Intel i7-8700, which is a 6-core, 12-thread processor with a fairly solid integrated GPU that we'll definitely make use of. We also get a single 8GB stick of DDR4. The motherboard is of course some OEM deal, which isn't optimal, but we do have a single PCIe X16 slot and 2 X1 slots, along with 3 SATA 3 ports. The chassis itself is fine. I mean, it's your run-of-the-mill big box office PC case, so fairly compact, but it's got weird mounting points for stuff, so again, not optimal, but whatever. With about $80 left, I knew I would need more than 8GB of RAM, so I doubled up with another 8GB stick for just $10.
Whoa, Brett, I see 4 slots in there. Why not buy more?
Let me get through all the parts first, then I'll explain my reasoning shortly after. Deal? Okay, let's get some storage in here. I 100% knew that for this budget, I wanted to go with NVMe, since that's going to be so much better than SATA drives, even SSDs for hosting multiple VMs. You'll probably notice that we don't have any NVMe slots on our motherboard though. No worries, for just $5 you can snag a PCIe to NVMe card off of AliExpress. These things are comically cheap these days. For the actual drive, we went with a 512GB Samsung OEM drive that was pulled out of something, I don't know, but it was only $25 off eBay. So yeah, what else do you need in here? Well, it's 2024, so we can't just be sitting on 1 gigabit networking. Let's upgrade to 2.5. I snagged a 2.5 gig PCIe card, which can be found for around $15 on eBay. I didn't buy this one specifically for this video since I had one on hand, but you guys get it. Now surely that's enough networking, right? Wrong. For $20, I snagged a dual 1 gig NIC, which will officially use up our last vacant PCIe slot and put our grand total at $196. Yes, I know you're immediately heading to the comments to tell me I spent my money wrong and that for 2 nickels and like 10 minutes behind a Home Depot, you could have gotten an entire rack full of gear. Congrats. Now, spending so much on the base system, I think was a no-brainer, to be honest. The 8700 by itself goes for about $50. Then when you factor in a chassis, motherboard, RAM, power supply, and CPU cooler, I think that's worth the extra $70. Could I have gotten super sweaty and searched around for matching parts for a 6th generation old platform to save like $10? Maybe, but to have it all in one, I think was worth it. I specifically chose this build around the 8700 since it's the first year Intel jumped from 4 cores to 6 cores on their i7 models, and it's also hyper-threaded, so we get 12 threads and a decent integrated GPU on a decent package. Only going with the 16 gigabytes of RAM isn't really that deep. I just had to save money somewhere, and since I'm obviously not using this as a NAS and running ZFS, then 16 gigabytes should be fine. The NVMe drive was important to me since now that we have a CPU that is capable of running plenty of services and VMs, I needed storage that could keep up. Upgrading to 2.5 gig I think was a bit necessary as well since we clearly won't have bulk storage on the system, so if we do need to access storage on another system, we'll be happy that we have more bandwidth to do that. Then comes the dual 1 gig NIC. Why? Well, this one's kind of a wild card and I snagged it because I think it'd be cool to host or test network virtualization like PFSense, OPNsense, or whatever firewalls you want. Having a dedicated NIC with a port for WAN and LAN makes this a much easier experience. So yeah, that's my justification. Is this the perfect server? No, come on, it was $200. I will say that for $200, you certainly have more options to customize your build than you do at $100, so feel free to swap out whatever. Alrighty, software time. Last time I went with Unraid because, well, I felt like it, and I deservedly got some comments about the cost of Unraid not being factored into the overall price. This time we are going with Proxmox, which is my personal choice for my servers in my home lab. First thing I always do when installing Proxmox is go in and remove the enterprise repos and add the no subscription ones. Then, of course, update. Now we have an updated, clean Proxmox instance to start with. I did want to test out my cheap NVMe setup and 2.5 gig card, so I did some basic benchmarking with iPerf and FIO. The 2.5 gig NIC works exactly as expected, giving us almost the max 2.5 gigabit throughput, so no complaints there. Running FIO for sequential reads and writes is probably the best way to get a flat raw speed number for your disks, and our NVMe drive performed okay. Both our reads and our writes came in just below 2,000 megabytes a second, which is maybe slightly less than what you'd expect out of a mid-range Gen 3 NVMe drive, but for what I paid, that's plenty. For comparison, I ran the same test on my main server that has a Gen 4 Samsung drive and got double the performance. So yeah, I mean, for what we paid for our NVMe drive and the 2.5 gig card, I'm happy with this. To test our raw performance of the CPU, I ran Geekbench, which gave us a single core score of 1652 and a multi-core score of 6560, which I mean is pretty on par with what you'd expect if you just Googled i7 8700 performance. As for the power draw at idle, with a few things running, it was pulling about 15 watts, and during our Geekbench test with the CPU pinned on all cores, it pulled up to 170 watts. Honestly, not too bad. The idle's really good, but I would have liked to see maybe a bit less when it was stressed, but I mean, I can't complain. Now, the first real thing I wanted to do on here was to utilize that dual 1 gig NIC and set up an OPNsense firewall. There are two ways you can go about doing this. One way is to pass the entire NIC to the VM using PCIe pass-through. This will have OPNsense see the entire card, which usually has the best chance of working without any issues and ensures peak performance. The downside though is that once you pass the NIC through, the host can no longer access it. For you, that may be perfectly fine, but I'm going to do it the other way, which is to first create a bridge network for each of the ports on my NIC on the Proxmox host. This essentially ties each port to a virtual interface that we can then pass through to our OPNsense VM as regular old network interfaces. The reason I went with this is because once we configure each of those bridge networks as a WAN and a LAN in OPNsense, then we can reuse them for other machines on our host. For example, I spun up a Linux Mint VM and used the LAN bridge from OPNsense as the main network, which means Mint is operating off of our virtualized OPNsense firewall. This is extremely convenient for setting up test networks, trying out new firewalls, and just having an all-in-one system. I even went into OPNsense and set up a guest VLAN complete with its own DHCP server, which then allowed me to set that VLAN tag on the bridge network in Mint. And just like that, our Mint VM is operating on our new guest VLAN. Even better too is that we can still use the physical ports on the NIC, so I could just plug in a switch to the LAN port and have a whole network running off of our OPNsense firewall. In terms of performance, I really don't know if using bridge ports is any different than passing the NIC through, but my guess is no, unless you're running a massive network with like a crazy amount of bandwidth. In terms of OPNsense itself, I've actually never really used it, and in my 10 minutes of trying it out here, I definitely say that pfSense has the upper hand when it comes to intuitiveness. Like, why is there no way to tell which options in the side menu have sub-options without clicking? The next thing I wanted to do was to make use of the integrated GPU on the 8700. Intel has famously capable iGPUs when it comes to transcoding, which is what we'll be doing. The most common use case for having hardware transcoding is for a media server like Plex or Jellyfin. This allows your media to be transcoded into a different format in real time for different devices without having to stress the CPU at all. There are plenty of ways to go about setting this up, but what I'm going to do is spin up an LXC and run Docker in there. I'm going with an LXC since it's much easier to share resources from your host like an integrated GPU than it is on a virtual machine. The next decision is whether to do a privileged or an unprivileged container. And I'll probably get roasted for this, but I went with a privileged container since it's just easier to get things set up, and I'm the only one using this and it's not really running anything production. Most of the time, you'll want to set up an unprivileged container, which is more secure for various reasons, but it is a bit more tedious to set up proper user permissions and device pass-through. There are plenty of guides out there on how to do it, so I'll leave it up to you to choose your fate. Anyway, I installed Docker, set up Portainer, and created a Plex template that would map to my NAS that holds all of my media. In a lot of cases, your Plex instance will probably run on the same machine as your media, but remember, we don't have any mass storage on here, but we do have 2.5 gig connection to any external media that we want to connect to. Yeah, big brain stuff right there, right? After ensuring that our devices are properly passed through to our container, we can see that Plex is using our iGPU for real-time transcoding. Now, I'll be honest, the 8700 is plenty powerful enough to do software transcoding for a small Plex server, but this isn't just a Plex server. The idea is to see how much we can get out of a $200 server, and saving CPU resources by using an iGPU is one way we can do that. And guess what? We aren't done with the iGPU. I also spun up a Handbrake container, which not only gives us a web UI for manually transcoding media, but it also has a feature where it'll monitor a specified folder and automatically transcode anything that gets dropped in there. Since our iGPU can be shared to as many Docker containers as we want, there was no issues using QuickSync in here. Dropping a movie into our watch folder and waiting about 5 seconds kicked off the process and we were good to go. And there are different reasons for setting up something like this, the main one being to automatically convert any media that you legally obtain into a more efficient codec or resolution. And the other is for creators who want to offload all their footage and automatically create proxies for editing. And honestly, this works perfectly for that. At this point, we're already getting a ton of use out of this machine and we're barely touching the CPU. This gives us plenty of horsepower to run everyone's favorite operating system, Windows 11. Yeah, I know, down with Microsoft, I get it. I mean, look at how obnoxious the install experience is. Like, what is this? But unfortunately, some software only runs on Windows, so if you need a Windows VM, we have plenty of resources for it. If you have room to put in a GPU, you could also pass it through and set up a nice little cloud gaming rig. Unfortunately, I'm out of physical PCIe slots, so that's not really an option here, but maybe something that you want to do. From here, it's really up in the air for what you want to do, because with 6 cores, 12 threads, and 16 gigabytes of RAM, it's not going to be something that you're going to be spinning up 100 VMs on, but for a few virtual machines and maybe a test K3X cluster and a Docker LXC, it'll do just fine. Remember, this was $200, so there's obviously trade-offs. Your trade-offs may be different from mine too. Maybe you went with the cheaper SATA SSD and no dual NIC to snag a cheap GPU. Maybe you go with a lower SKU CPU to have money for some hard drives. This whole thing wasn't to say, if you have $200, this is what you have to buy. It was more to just show one way you can make your $200 work. At the beginning of the video, I mentioned that we'd see if spending double the money would lead to double the performance, and that's usually never going to be true. Sure, we more than doubled the speed of our boot drive going from a SATA SSD to an NVMe drive, but we also don't have any bulk storage now. If you want to talk about CPU horsepower, we did go from 4 threads to 12 threads, which again is more than double, but that doesn't really translate to double the performance in real-world use cases. I will confidently say that spending $200 upfront seems to be better than spending $100, then spending a second $100 later. So I guess don't let that stop you from building out a $100 server, but if you do have the means to spend a little bit more, I'd say the 8700 is a really good value on the used market. Overall, I'm very happy with the system. I think we can get plenty of use out of this server, not just as a cheap build, but just in general. We also have a solid base for upgrades if we want to add more RAM and mass storage down the line. Maybe we run this back and see how it stands up against a $400 server. But at some point, this has to stop though. I can't be building out a $13,000 server next year, or can I? But that's all I have for this one. Let me know down in the comments what you thought or what you would have done differently with your $200 budget. If you liked the video, then drop a like and subscribe if you want to see more. I want to give a huge shout out to my YouTube members and my Patreons. You guys are my $200 server with so much horsepower and raw performance. You guys are beefy. And if you're still watching, you're a privileged container. Thank you so much, and I'll see you in the next one.